Now let us continue. We will talk about distributions and how can we use distributions to analyze certain properties of the images and how we can track the changes that we are applying or the transformations that we are applying to the images. So I have prepared in advance this function that will plot a distribution of a separate channel of the image for us. And as usually, I will copy this cell completely and leave the previous one with the background subtraction for the history. Let's put it like this. So here we have a function that is supposed to plot a distribution for us, and we'll move it over here. And I will have to do some changes. So first of all, we don't need that. Oh, no, we do. But so it will be just, let's say, frame. What's the idea here? We are going to plot the distributions of red, green, and blue channels in the image, and then we will try applying some transforms in HSV color space, and then we will try to track what's going on with those distributions. So let me delete the background subtraction related stuff from here. We don't need it anymore. And we don't need any connected components analysis. We just have to read the frames of the video in the loop, and that will be fine. So first of all, let's comment even this. Now I'm going to plot the distribution for the channel number 0 of the input frame. Dist 0, I will call this function. What is going on in the function, by the way, is the following. The core part is this one. We are first flattening the whole input array that is supposed to be two-dimensional input. And we are placing all the numbers into 285 bins, and all the values that are supposed to be accepted in those bins are from 0 to 256, not included. So that's just the whole range of the image. And after some transforms, we get the image, the standard NumPy image that you can visualize with this plot. So first, let us call this plotDist function from the channel number 0, and let's visualize it. Okay. Have to import the matplotlib library. Okay, it's working. So what do we see here? This is the distribution of, not yellow, never mind, this just a yellow plot. That's a default color scheme by Matplotlib. So this is the distribution of the pixels in the red channel. And you can see that as the object is moving here and as the time passes, the shape of the distribution doesn't really change that much. The whole scene is almost stationary and nothing is changing. What I would like to do here is I would like to attach those plots to the original image, maybe. Or maybe just we can gather them into one big chunk of plots. So let us plot them in a united form. Distributions, and I will concatenate all these images. And the axis will be, at some point I will memorize that, but not now. So let's try. Yes, that's the proper one. Okay, so now we will not attach it, let's skip it altogether. The most important thing here is that those distributions are in the RGB color space, and they are pretty much not sensitive to the slight changes in the color and noise in the camera. You can see that the distributions are changing, but not that much. And now we can do the same thing, but in the HSV color space. Okay, so here it's pretty much the same. Whoa. What's going on? Yes, it's finished. So what I propose to do is I propose to add some values to those channels, to the whole basically channels, to all the values of the pixels in the channels. And we can do that with 3 track bars. We'll do it later. And now we can try it in the simpler way. We can create a variable, and we will add the value of this variable to the channel number 0, to the color tone. HSV frame, everything 0 plus equal I. And after that we will increment I. Okay, one more thing that we can do is we can use, let's say, each 10th element over here, because that will be much faster. We can calculate the distribution using just 1/100th of all the pixels. And the shape of the distribution will be almost the same. So let's run and see what will happen. Okay, so these distributions are more noisy, that's for sure, but still they kind of make sense. So we can decrease the step to maybe 5. And yeah, one thing that I also have to do is I have to transform this HSV frame back because here we're applying some transform and then we're doing basically nothing. We're not showing it anyhow. So here will be color conversion from HSV frame back into the RGB color space, or BGR to be precise. To BGR, okay. So what do you expect to happen? Do you see any changes in the appearance of this image? The thing that is happening could be seen in the distribution in the H channel over here. So you can see that all the distribution is shifting slowly to the right side. After some time, it will be exactly the same as it was before we began. So it will just loop through all the color space. And if we add 256, the value will not change. And now you can try to think about the following question. What will happen if we will add certain values in the same manner in saturation channel and in value channel? What do you expect to happen? Now we'll do that. And here I will leave it to, let's say, 4. That will take slightly more time, but the distribution will be less shaky and less noisy. And here I can decrease this maybe down to 80 milliseconds. Yep, so let's do it with the channel number 1. What do you expect to happen? Let's take a closer look at the saturation channel. Here you can see some artifacts arising. What happened? Well, the thing here is that since this car was very saturated, it had already high enough values in the saturation channel, and as a result, this channel has experienced an overflow, and the value of the saturation has become 0 or almost 0, slightly above 0, so that it's gray here. And the rest of the image is very saturated by now, so as the distribution is changing and shifting to the right, it becomes over the top saturated, and in a short time we will see the shift to the grayscale St. Petersburg type of color distribution over here, as the bigger part of this distribution, the higher part, the extreme, is moving more and more to the right. The picture appears less and less realistic, and in a short time we will see this shift. Yes, here it is, so it's appearing. And finally it's just almost normal grayish type of picture. And the same thing starts to happen again over here on this car. So this whole process is basically looped. Now let us do the same with the channel number 2, with the brightness. Try to think, just pause the video and try to think about what's going to happen. And we will see in an experiment. Okay, so here we can observe an overflow clearly in the brightness channel at the brightest spots of white and blue. And these areas, they grow Some of these areas are on the windows and on other bright spots. And we will see this shift to the darkness as this distribution will move through the right side to the very left. And after a short time, it will start to be normal again. So we're very close to the original distribution as far as I can tell. It's very stylish, isn't it? It reminds me of modern clip making. So except for a certain amount of artifacts, we're pretty much done, and we are almost, here, yes. So here we have no artifacts, and that's the original image, basically. And here it starts from scratch. So what can we do now is we can create a couple of track bars, or let's say 3 track bars, for the values that we're going to add to all 3 channels. I have created a named window, which is frame, and I'm going to attach those track bars to this frame window. H, Shift, whatever. Frame. The default value will be 0, the maximum value will be, let it be 256. And here will be this dummy function that will do nothing. Saturation shift and value shift. Okay, so now we're going to read the values of these track bars. Get track bar position, track bar by the name of H shift, hue shift, from the window frame. We'll delete this I counter. And I will write here the proper values for the numbers of the channels. I think we're done. So let's run the code. Indeed. This bug is pretty disturbing. Okay, but still. Let us try moving this track bar that is responsible for the color tone or the hue. Let's move it. It's laggy. Well, we have to live with this somehow. We'll have to reload the kernel and increase this value. This poor thing is not working properly because it's working in a single thread. So we're interpreting everything, all the comments one after another, and because of the distribution calculation that takes a lot of time, we have relatively low frames per second ratio and those freezes. And also the computer is, you can say that it's more portable than powerful. Okay, so let's try doing that again. By the way, at some point with the introduction of some new version of OpenCV, it has become worse, at least under macOS. And yes, here you see those bugs. So that's clearly not very cool, but we have to deal with it somehow. Well, they're not moving properly. Okay, so if I press it, it's fine. Okay, so what's happening here is that wait, what? Okay, so I'm changing manually the value that I add to the hue channel. And here you can clearly see that the whole spectrum of the colors in the image is changing. Let's roll it back to 0, and this is the normal image. Let's do the same with saturation. Yes, here we see an overflow, for sure. Yes, and if we move to the left side, well, if we move very far to the right side, it's overflowing at almost all the image, and as a result, in the areas with overflow, we can see that they are darker. Oh, not darker, but less saturated than in the original image. Okay, let's do the same for the last channel, for the brightness. Or, you know what, let's try to do it in a more smart way. First, let's change this for, I don't know, 30. So we will take much less pixels from the frame to calculate the distribution in order to make it faster. And another thing that I'm thinking of doing is I'm thinking of changing this value to 100, the default value to 100. And here we can subtract 100. Why so? That's for us to be able to decrease the saturation and decrease brightness. Because here the values are 100 and we are adding 100 minus 100, so we're doing nothing to the image. And here I will try to manipulate the saturation channel. So let me decrease it. I'm decreasing the saturation. Seems like it doesn't work. That's because some of those values well, basically, if you're moving the trackbar to the left, this value becomes negative, and we cannot do that with images that consist of np.uint8 data type. So we have to use something different. First, we have to kill the kernel, and after that, we have to use a function that is called cv2.add. Not weighted, just add, and that's it. And yes, it's not an in-place operation, so we can do it in the following way. HSV, it works with well, it's supposed to work with three-dimensional arrays, right? Okay, so it will be HSV frame or not. I don't think so. I don't think that it's going to work. So let's add a value to the channel number 0 and the rest of the channels separately. We're almost there. HSV. Done, I guess. Nope, not really. Okay, now we're done. So I have moved the trackbar to the left, and the image has become less saturated. It's almost grayscale by now. And if I move it to the very left, the only saturated parts are those that were originally very much saturated. So this blue color and this yellow part. And regarding the distribution here, you can see that the whole distribution has shifted to the left very much. And it's being cut by 0, so it doesn't shift to the left and beyond the 0 point, so it doesn't appear on the right, because of the OpenCV functions properly handling this. And if we want to bring this whole image to the grayscale, to the complete grayscale, we have to increase the range of this whole thing. So we can do that, why not? So let's check. Let's check, and this default value will be 256, and here we have 512, and the same will be done for the rest of the channels. We are doing almost the same stuff that you can do on your phone or your computer while digitally manipulating the images in the photo editor, but we're doing this with code. So there you can apply some filters, in particular grayscale field. Oops, no. That's because here I was too lazy to introduce a constant to that. Now I have to copy and paste things. Okay, So finally, we can change the distribution. And here you can see that it's approaching the left side, right? And it was like this previously, and it has already had low values in the saturation channel over here. And if we're changing this distribution, if we're moving it to the left, there are less and less saturated pixels here. And with the distribution like this, there is a tiny little bit of saturated pixels with the saturation other than 0 over here. And we can move it to the grayscale completely, like this. So it's a complete grayscale. And now let's roll it to the different side. We can see some bits of saturated objects appearing as I'm moving the distribution to the right. Here it's slightly more saturated than it was originally. Here it's considerably more saturated and even more. And this looks like a fever dream already. And this looks like I don't know what even. So this is the most saturated image that you can get. Let's do the same thing, but with different color channels. With the hue, with the color tone, it's pretty much clear what's going on here. So we're just moving through this color space, and colors are going all around the rainbow. We have seen that already. So let's get back to 256. And now let's move the last track bar, which is responsible for brightness. It's becoming darker and darker. I can barely see anything here because the distribution is very much at the lower values of brightness. So let's shift it to, yes, there are some shapes of cars distinguishable here, but not much more than that. And here we cannot see just anything because the whole distribution has precisely 0 as the global maximum, and the really one value that all the pixels have is 0 in terms of the brightness. So the image was completely black. And now let's try making this image brighter. Here it was with the default value. The video was captured during the evening, so it's dark. And now we can try to move this distribution to the right so that it could appear from the first glance that this frame was taken during the day. We can try. That's slightly too much, right? So here are some artifacts, and it doesn't appear really natural. And almost, yes, so it's cartoonish, and we cannot trick anyone with that. But here, if we play around with saturation, like this maybe, it could seem, well, except for those artifacts, it could seem like a daylight video that was just taken with some strange color settings. So, analyzing these distributions, we can understand how do the pixels group together, and what are the main parts of this distribution of this image in terms of the dominant luminosity and color and saturation blocks or blobs. So while looking at this distribution, we can think of altering it somehow, of moving it or shifting it towards certain directions. If we want to manipulate the whole video, if we want it to appear darker or more saturated, we can easily do that with OpenCV. That's it for the seminar.